Hi, so for today we're going to talk about the auxiliary equation, and this is a continuation of our last video all about differential equation wherein we tackled auxiliary equation but with distinct roots. But now we're going to talk about auxiliary equation with repeated roots. Okay, so consider some higher order differential equation and we're going to solve it. Okay, we will be using this formula. So we have y is equals to c sub 1 e raised to m sub 1 x, of which m sub 1 is the one of the roots, okay, multiplied by x, plus c sub 2 x e raised to m sub 2 x. So as you can notice here that on the first term, we don't have any x term multiplied by c sub 1. But on the second term, okay, we have c sub 2 multiplied by x. And of course, in third term, C sub 3, it would be x raised to 2. Okay? The power of x, okay, from first term up to the last term, well, it depends on how many roots, is actually increasing. Okay? As it repeat the roots. So we have C sub 1 e raised to m1x, C sub 2x e raised to m sub 2x, C sub 3x squared e raised to m sub 3x, and so on, so forth until we have c sub n x raised to n minus 1 e raised to m sub n multiplied by x. But since if we are going to solve some higher order differential equations, okay, using differential operators and auxiliary equations, since if all of the roots are repeated, meaning they have the same set of roots, okay, so since m sub 1, m sub 2, m sub 3 is equal to m sub n, we can rewrite this whole solution to our differential equation that has repeating roots as this, c sub 1 e raised to m multiplied by x. So all are replaced by simply m because they are all equal. They are repeating roots. So what will happen is that we can factor out e raised to m, okay, e raised to m multiplied by x, such that we will be having the general solution for these differential equations that has repeating roots as this, as the quantity of c sub 1 plus c sub 2x plus c sub 3x squared plus until c sub n multiplied by x raised to n minus 1, because as you can see here, the n is the number, okay, m sub n. If our n is 3, then definitely the exponent of x is 2, so x squared. So if whatever number it is, x is simply raised to n minus 1. So we have this general solution for our differential equation. So please take note of this, okay. So, in order for us to really understand, okay, let us try to solve some problems. So, for example, we are given this problem wherein we are asked to find we have the fourth derivative of y with respect to x plus 2 times the third derivative of y with respect to x plus second derivative of y with respect to x is equal to 0. So, now first we're going to write this into a differential operator. Okay, we know that this should be d raised to 4 multiplied by y plus 2d cubed multiplied by y plus d squared multiplied by y is equals to 0. We have to factor y such that this becomes this, okay? And finally, we are going to put this into an auxiliary equation. So what will happen, if we put this into auxiliary equation, we have m raised to 4 plus 2m cubed plus m squared is equals to 0. Again, we will still solve for the roots or for the values of m. Okay, since we have here raised to 4, of course, we have 4 roots. But as you can see, we can factor m squared from this whole term such that this would become m squared plus 2m, okay, plus 1. So you can see we have m squared is equals to 0. So m squared is equals to 0, and we have here, if we're going to factor this out, okay, if we're going to factor that out, let me just erase this. Okay, that would be m, okay, plus 1 times m plus 1 is equals to 0. We know that this is still 2 roots, so we have m sub 1 is equals to 0 because this is raised to squared, and we have m sub 2 is equals to 0. And from here, we have 2 repeating roots again, of which that is m is equals to negative 1 and m is equals to negative 1. This should be m sub 3, m sub 4. Okay, so if we're going to write that to our general solution, okay, what will happen is that we'll be having y is equals to c sub 1. Okay, first we have the two repeating roots. Okay, so the first c sub 1 should not have any x, but it is multiplied by e raised to 0 times x. Okay, plus, again, it repeats. The other 0 repeats. So, we must continue the equation, the general equation that we have seen a while ago. So, this should be x. So, e raised to 0 times x. And as you can see, the other roots are also different, but they are repeating. So, what will happen is that you will add again c sub 3. You will start again with 0, with no values of x, with no multiplied by x. So, what will happen? E raised to negative 1 times x plus, again, since this is negative 1 again, continue the cycle. So, c sub 4 multiplied by x. Again, e raised to negative 1 times x. So, to simplify this, we can see that e raised to 0 is simply 1. E raised to 0 is simply 1. So, this c sub 1 should be, this term should be equal only to c sub 1 plus c sub 2 times x. Okay? Plus, we have c sub 3 e raised to negative x plus c sub 4 e raised to negative x. And as you can see here, we can factor out e raised to negative x from both c sub 3 and c sub 4. So we have c sub 1 plus c sub 2 x plus quantity c sub 3 plus, this should have an x, okay? So let me just erase it. So I'm so sorry, I forgot the x. So this should have the x, e raised to negative x. So plus c sub 4x multiplied by e raised to negative x. So this is now the solution to our differential equation. So let's go now to our second example. For our second example, we need to solve d squared minus 6d plus 9. Okay, this is a differential operator. So first, what are we going to do? Write this into our auxiliary equation. So we have m squared minus 6m plus 9 is equals to 0. So this is a pretty easy one, okay? Because if we factor this, we have m minus 3. Okay, if we factor this, m minus 3 is equals to 0. So as you can see, m sub 1 is 3 and m sub 2 is 3. So this has a repeated roots. So if we're going to write this on our solution form, so we have c sub 1 e raised to 3x, that's m sub 1, plus we have c sub 2 multiplied by x since it repeats at 3. So we have e raised to 3x, and we can therefore factor out e raised to 3x. So we can have quantity of c sub 1 plus c sub 2x multiplied by e raised to 3x. And this is our solution for this differential equation. Okay, so let's try another problem. By the way, for this video, I'm going to have only 4 problems. For our next problem, we have this problem, d raised to 4 minus 7d cubed plus 18d squared minus 20d plus 8 multiplied by y is equals to 0. So this is a differential operator, and then we're going to convert this into auxiliary equation. So we have m raised to 4 minus 7m cubed plus 18m squared minus 20m plus 8 is equals to 0. So what are we going to do? We are going to find the roots, okay? And as discussed on my previous video about distinct linear factors or distinct linear roots, so we'll be labeling this as, in order for us to factor this, we have q and p. And all of the possible solutions, okay, of this or roots of this is given by p over q, the multiples of p over q. So we have the multiples of p over q, multiples of 8. So we can have positive or negative 1, positive negative 2, positive negative 4, positive negative 8 over the coefficient of this is 1. So positive or negative 1. Okay. So all of the combinations that are of this could be a possible roots, but not all. Okay. So what we will be having a process of trial and error. Okay, but let's try to have a root of p over q. Okay, of let's say positive 1 over positive 1, and that is equal to 1. Let's try this. So what I'm going to do next is to apply the synthetic division. Okay? We will be dividing this whole equation by 1. So we're going to get the coefficient of each term. So we have for the m raised to 4, we have 1. For the m cubed, we have negative 7. And for the m squared, we have 18. For the m, we have negative 20. And for the constant term, we have the 8. Perform synthetic division. Bring down 1. 1 times 1 would be 1. Okay? Negative 7 plus 1 would be negative 6. Negative 6 times 1 would be negative 6. So 18 minus 6, that would be 12. 12 times 1 would be 12. Okay, and add this to, we have negative 8. Negative 8 times 1 would be negative 8. And negative 8 plus 8 would be 0. Therefore, m sub 1, our root is 1. As we can see here, we have 4 roots because it is raised to 4. So we have already solved for 1. Okay? So this now would be our new coefficients for our given auxiliary equation. Given that we're going to reduce this, okay? So we're going to reduce the highest order or the highest degree is would be 3. So we can write this as m cubed, okay, because it has only 1, minus 6m squared. So this becomes the coefficient of the m squared, plus, okay, this is the coefficient of m, minus 8 is equals to 0. And from here, again, we're going to solve again for the roots. And all of the possible combination or possible roots, okay, this should be our q again, and this our p. And the ratio or let's say p over q, the multiples of p over q contains all of the possible roots of this. So we have again, we shall be having the same positive negative 1, positive negative 2. That's the multiples of p, positive negative 4, and of course itself. And of course, for q, that's again positive negative 1. Okay? So, we're going to try what if our P over Q would be, let's say, positive 2 over positive 1, and that is equivalent to 2. Okay? So, we're going to divide by synthetic division again by 2. So, if you can see here, we can write the coefficients again, 1, negative 6, 12, and negative 8. 1, negative 6, 12, negative 8. Perform synthetic division, bring down this. 1 times 2 would be 2. Add this would be negative 4. Negative 4 times 2 is 8. Negative 8, I mean. So 12 minus 8 is 4. 4 times 2 is 8. Negative 8 plus 8 is 0. Therefore, again, we have another root which is 2, because if we divide this, it has no remainder. Okay? So we have m sub 2 which is equal to 2. And again, since we have already divided this by another root, so this should become the exponent or the coefficient of m squared. Okay, this one. And this should be the coefficient of the simply m. And this will now be our new constant. So we have reduced the given auxiliary equation into this by dividing the equation, again, this equation by its root 2. So we have reduced the equation. And by this, we can simply factor this out. Okay? So we have m minus 2 multiplied by m minus 2. As you can see, we have another root, m sub 3, which is 2. Another root, m sub 4, which is 2. So we have already solved the 4 roots. So again, let me just rewrite our root a while ago. M sub 1 is equal to 1. So how do we write this? As you can see here, we have a distinct linear root. Okay, so we have distinct 1 and 2. So how are we going to write this? Therefore, our solution would be y. So these two are distinct. So we have c sub 1, okay, e raised to m sub 1, okay, 1 times x for distinct. And we have m sub 2, c sub 2, e raised to 2 times x, okay, for a distinct factor. So we have plus, this is repeating. So we have c sub 3 e raised to, let's say, 2x again, plus, since this is repeating, c sub 4, we have to add x here, multiply x, and this is e raised to 2x. Upon simplifying, we have c sub 1 e raised to x plus c sub 2 e raised to 2x, okay, plus c sub 3 e raised to 2x plus c sub 4 e raised to 2x. That is multiplied by x, I mean c sub 4x. So c sub 4x e raised to 2x. So this term, this c sub 3 does not have any x because the form of writing repeated roots on the very first term, even though this is not c sub 1, is still we don't have any x. Okay? So don't be confused on that. So this is a distinct root, 1 and 2, and we started our repeating roots at c sub 3 and c sub 4. Okay, so as you can see here, we can factor out some of the common factor here. So e raised to 2x, so we have c sub 1 e raised to x, plus common here among these terms are e raised to 2x. So we have c sub 2 plus c sub 3 plus c sub 4x multiplied by e raised to 2x. So that should be our solution for this given problem. As you can see, we have 4 roots. So this is our answer. Okay, for our last example, okay, this will be our last example for number 5. For number 5, we have the 4d raised to 5 minus 23d cubed minus 33d squared minus 17d minus 3 multiplied by y is equal to 0. And first, we have 5 roots because this is raised to 5. So we can rewrite this in terms of auxiliary equation. So we have 4m raised to 5 minus 23m cubed. So you can notice there is no 4th degree term. Minus 33m squared minus 17m minus 3. Okay, is equal to 0. In order for us to find the possible factors that would make this equation 0 or true, okay, or the roots. So we can label this as Q, and we can label it as P, and our P over Q factors are, okay, for our P, that is positive negative 1, positive negative 3 over the 4, positive negative 1, positive negative 2, positive negative 4 itself. Okay, so these are the possible, okay, roots. So you have to try trial and error, okay, by using syntactic division. If the there is no remainder, means that it is the root. Okay, so let's try. Okay, let's try to pick as positive 3 over positive 1. So that is 3, simply 3. So we're going to divide this whole equation or this polynomial, okay, by synthetic division by 3. So we have 4. This is raised to 5. So you have to be consistent. Raised to 5. Raised to 4. There is no term that is raised to 4. So you have to put 0. Okay? And for raised to 3, we have for the cube. And for the square term, we have the coefficient negative 33. And we have negative 17 and minus 3. Okay, bring down 4. So we have 4 times 3 would be 12. Add this 2 would be 12 still. 12 times 3 is 36. Okay? And we add this 2, negative 23 plus 36 would be 13. 13 times 3 is 39. Add this 2, so we have 6 here. Okay? And 6 times 3 would be 18. Add this 2. what will happen? That would be 1. 1 times 3 is 3. Negative 3 plus 3 would be 0. Therefore, m sub 1 would be 3. Because there is no remainder, okay, upon dividing, our answer or remainder is 0. So that is a root. So this equation reduces now to, this would be the coefficient of raised to 4. This would be the coefficient of cube. Okay, this would be the cube. This would be the coefficient of m squared. And this should be the coefficient of m, coefficient or the constant 1. Okay, so again, we have to apply the same rule. This is our q. This is our p. So the possible roots, p over q, are the multiples of p over q. So I have positive negative 1 on the numerator, and we have 4q. We have positive negative 1, positive negative 2, and positive negative 4. So what are we going to do? Again, let's try. Okay, let's try, let's say, positive 1 over negative 1. So that is negative 1. Okay, so we can divide this by negative 1. So get the coefficients again. So 4, 12, 13, 6, and the constant 1. And let's see if we divide this, we'll be able to get a 0 remainder. So we drop down 4. 4 times negative 1, that's negative 4. We add this 2, that would be 8. 8 times negative 1 would be negative 8. 13 minus 8 would be 5. 5 times negative 1 would be negative 5. 6 minus 5 would be 1. Okay, 1 times negative 1 is negative 1, and 1 minus 1, 1 plus negative 1 would be 0. Therefore, again, okay, therefore we have an m sub 2, which is negative 1. Okay, that's another root. Okay, that's distinct. That did not repeat. Okay, so what will happen again? This would now be, if this is m raised to 4 a while ago, this should be m raised to 3. This should be the coefficient of squared, 8m squared, plus 5m plus 1 is equals to 0. And again, we have q, we have the p, and the possible roots, again, by synthetic division, we have positive negative 1 for p, and again, positive negative 1 and positive negative 2 or positive negative 4 of itself. So what are we going to do is, let's try. Okay, let's try, let's say, negative 1 over positive 1. Okay, negative 1. Let's try again, negative 1. If we divide this by negative 1, we'll be able to get 0 as our remainder. So again, we have to bring down this. 4 times negative 1, that is negative 4. 8 minus 4, or 8 plus negative 4 would be 4. 4 times negative 1 would be negative 4. 5 plus negative 4 would be 1. 1 times negative 1 would be negative 1. And we add this to 1 plus negative 1 would be 0. Therefore, another root is, it repeats. Okay? Our m sub 3 is now negative 1. Therefore, our equation, if this is q a while ago, this would be the coefficient of m squared. So we have 4m squared because of this, plus 4m because of this, plus 1 is equal to 0. Now, this is easy to factor since this is only square. So we can divide this whole equation by 4. So we will be having m squared plus m plus 1 over 4 is equal to 0. And as you can see, if we are going to factor this should be equal to m plus 1 half. Okay, and m plus 1 half is equal to 0. As you can see, we have another repeating roots. So we have m sub 3 is equal to negative 1 half. And m sub 4 is negative 1 half. Therefore, m sub 4 and m sub 5. So this should be m sub 4 and m sub 5. Because this would be the final step that we're going to solve for the roots. So we have 5 roots. So we have 3, negative 1, negative 1. So we have 3. We have m2, which is negative 1. And we have m3, which is again negative 1. Now, it's time to write for the solution. So, This is a distinct, so we have c sub 1 e raised to 3x. That's the distinct. And this is repeating, as you can see. So we have plus c sub 2 e raised to negative x, because negative 1 times x is negative x. Since it repeats, so we can have c sub 3 multiplied by x. Okay, again, e raised to negative x. Okay, because negative 1. Okay, and another set of repeating roots, we have here m sub 4 for negative 1 half, and m sub 5 negative 1 half. So we can back to c sub 4, but we don't have any x again, because this is a new set of repeating roots. So we have c sub 4 e raised to negative 1 half x, okay, plus, since it repeats, another is a negative 1 half, so we have c sub 5 x e raised to negative 1 half x. So to simplify, we will be having c sub 1 e raised to 3x plus, we can factor out e raised to negative x here. So we have quantity c sub 2 plus c sub 3x e raised to negative x plus, we can factor out e raised to negative 1 half x here. So we have c sub 4 plus c sub 5 x raised multiplied by e raised to negative 1 half x. And this should be our answer for our differential equations. Okay, or equation given. So I have an exercise for you. You can answer this. Okay, and I will be giving you the answer, of course, for you to verify if you are going to get the correct answer. Okay. So this one is for you. This is 24. Okay. This is 24. And the answer is, I'll give you, okay? The answer is y is equals to c sub 1 e raised to 3x plus quantity c sub 2 plus c sub 3x plus c sub 4x squared e raised to negative 2x. Okay, so I hope you learned something from for today's video. This is the auxiliary equation with repeated roots. So thanks so much for listening. If you are new to my channel, please don't forget to give this video a thumbs up and comment down below your thoughts. And of course, please don't forget to subscribe to my YouTube channel. So thank you so much for listening, and God bless you.